Neutrinos. Something just passed through your skull, not near it, through every bone, every cell, every atom in your head, and out the other side of the planet. You did not feel it. You will never feel it, and it happened 100 trillion times in the last second alone. These are neutrinos. Subatomic particles with almost no mass and no electric charge. They interact so weakly with matter that a single neutrino can travel through a wall of lead, a light year thick, without touching anything. The sun alone produces 2, followed by 38 zeros of them every second. That number has no useful comparison. They flood the solar system at near the speed of light, passing through every planet, every moon, every living thing. At night, they travel through the entire Earth and hit you from below. Picture a rainstorm where every drop passes through your skin without leaving a trace. That is happening to you right now. Scientists built an entire detector under a mile of Antarctic ice just to catch one. The IceCube Neutrino Observatory uses a cubic kilometer of frozen water as a trap. Even then, it detects only a handful of interactions per day. Neutrinos outnumber every atom in the universe. They are everywhere. They are invisible, and they pass through you harmlessly. The next invisible thing does not. Cosmic rays. An invisible bullet hit you while you read that last sentence. You did not feel it because your body absorbed the impact without noticing. But the strongest ones are not so gentle. Every second, particles from deep space slam into Earth's atmosphere at nearly the speed of light. They come from exploding stars, colliding galaxies, and sources scientists still cannot identify. These are cosmic rays. They hit the upper atmosphere and shatter into cascades of secondary particles that rain down on everything below. On October 15, 1991, a detector in the Utah desert recorded a single proton carrying 320 exa-electron volts of energy. Scientists named it the "Oh my God" particle, one subatomic proton with the kinetic energy of a baseball thrown at 60 miles per hour, millions of times more powerful than anything the Large Hadron Collider has ever produced. When they traced its direction back into space, they found nothing. No galaxy, no black hole, no known source. It came from a void. Then in 2023, a second particle nearly matched that energy. This one also appeared to come from empty space. Scientists still cannot explain what accelerated them. And cosmic rays do not just hit the atmosphere. They hit electronics. A single cosmic ray striking a computer chip can flip a bit from a 0 to a 1. These bit flips have been blamed for airplane computer glitches, server crashes, and even voting machine errors. Invisible particles rewriting your technology every day. But cosmic rays are tiny. The next invisible thing is the size of a planet. Rogue planets. There are more invisible worlds drifting through the Milky Way right now than there are stars you can see. Billions of them, possibly trillions, and not one of them gives off a single photon of light. Rogue planets are worlds that were born in normal solar systems and then flung out by gravitational chaos. A close encounter with a larger planet, a passing star, one wrong tug, and a planet is ejected into interstellar space forever. No sun, no orbit, just ice and darkness. In January 2026, scientists published the first confirmed mass measurement of a rogue planet. A Saturn-sized world roughly 10,000 light-years away, detected only because its gravity briefly bent the light of a star behind it. That is the only way to find them. They reflect nothing. They are invisible unless they pass in front of something bright. Imagine looking at the night sky and knowing that for every star you see, there could be several frozen planets drifting in the darkness between them. Worlds the size of Earth, worlds the size of Jupiter, completely undetectable. The odds of one entering our solar system are about 1 in a billion over the next 1,000 years. Small, but not zero. Rogue planets are at least made of matter. The next invisible traveler is made of nothing but collapsed gravity, and it destroys everything it touches. Rogue black holes. Imagine something heavier than 1,000,000 suns moving through the galaxy at thousands of miles per second, and completely invisible. No light, no glow, no warning, just gravity so powerful it warps space around it like a lens. Rogue black holes are real, flung out of their galaxies by violent mergers or gravitational slingshots. They wander through the universe unbound to anything. They emit no light. They reflect no light. The only way to detect one is when it passes in front of a star and bends the image, or when it tears a star apart. In January 2022, Hubble confirmed the first detection of an isolated stellar mass black hole wandering through the Milky Way. In 2025, researchers found a rogue supermassive black hole devouring a star 600 million light-years away, far from any galaxy center. Scientists estimate roughly 12 rogue supermassive black holes could be wandering the outskirts of the Milky Way right now. The number of smaller ones could be in the hundreds of millions. Suppose one drifted through the outer solar system. You would not see it. There is no light, no sound, sound. You would only know when the orbits of distant objects began to shift. By then, the damage would already be spreading inward, silent, everywhere, the definition of invisible. But there is something in space that can kill you without ever coming close, without gravity, without contact, through nothing but an invisible field. Magnetars. A dead star 120,000 miles away could disassemble every atom in your body before your brain registers what is happening. Not with heat, not with radiation, with a magnetic field so powerful it tears apart the electron structure of matter itself. Magnetars are a rare type of neutron star, roughly 12 miles across, but their magnetic fields reach up to a quadrillion Gauss. Earth's magnetic field is about half a Gauss. A refrigerator magnet is about 100. A magnetar is 1,000 trillion times stronger than what holds a note to your fridge. At half the distance between Earth and the Moon, the field would strip your atoms apart. You would stop being a person at a molecular level. In December 2004, a magnetar called SGR 1806-2 released a burst of energy from 50,000 light-years away, the other side of the galaxy. The burst hit Earth's upper atmosphere and briefly compressed our magnetosphere. A dead star across the Milky Way physically disturbed our planet. For a tenth of a second, it released more energy than our sun produces in 100,000 years. Imagine the power of a star compressed into a sphere the size of a city, spinning hundreds of times per second, invisible to the naked eye. Magnetars kill with a field you cannot see, but the next invisible force operates on a scale that makes magnetars look microscopic. The Great Attractor. Right now, the Milky Way is being pulled towards something we cannot see at 1.3 million miles per hour, and we are not alone. Over 100,000 galaxies are being dragged in the same direction, towards something hiding behind our own galaxy. The source sits roughly 250 million light-years away. Scientists call it the Great Attractor, a gravitational anomaly with the pull of tens of quadrillions of suns, dragging everything toward one region of space, and we cannot look at it. The Great Attractor sits directly behind the thickest, dustiest part of the Milky Way's own disk, a region astronomers call the zone of avoidance. Our galaxy blocks about 20% of the sky, and the Great Attractor hides right behind that wall. Using infrared and X-ray telescopes, astronomers have partially pierced through. Behind the wall, they found the Norma cluster, a massive concentration of galaxies. Beyond that, the even larger Shapley supercluster. Together, they form the gravitational core of the Laniakea supercluster, a cosmic basin 500 million light-years across. Everything around us is falling toward it. But thanks to the accelerating expansion of the universe, we will never arrive. Something is pulling 100,000 galaxies at over 1 million miles per hour toward a destination they will never reach. The Great Attractor accounts for a region of space, but the next invisible substance accounts for most of reality itself, dark matter. Every star you have ever seen, every planet, every galaxy, every atom in your body, all of it makes up less than 5% of the universe. The rest is invisible, and most of it is something no one has ever detected. Roughly 27% of the universe is dark matter. It does not emit light. It does not absorb light. It does not reflect light. No telescope has ever photographed it. No detector has confirmed what it is made of. But without it, nothing you see would exist. Galaxies spin too fast. Stars at their edges move so quickly they should fly off into space, but they do not. Something invisible is holding them together, something with mass, something with gravity, and it outweighs all visible matter by 5 to 1. Picture a galaxy as a glowing city at night. Now imagine the ground, the mountains, and the sky around it are all made of something you cannot see, something that weighs 5 times more than the city itself. That is dark matter, the invisible scaffolding that holds reality in place. The LUX Zeppelin detector, buried deep underground, is the most sensitive dark matter experiment ever built. As of late 2025, it has found nothing. Every search has returned empty. We know it is there. We can measure its gravity, but we cannot find it. Dark matter holds everything together. The next invisible force does something worse. It is pulling everything apart. Dark energy. The universe is not just expanding, it is accelerating. Every galaxy moving away from every other galaxy faster and faster with every passing second. Something is pushing reality apart, and no one knows what it is. In 1998, 2 teams of astronomers expected to find the expansion slowing down. Instead, they found the opposite. Something was speeding it up. Something with no mass, no form, no source, no explanation. They called it dark energy. It makes up roughly 68% of the total universe. Combined with dark matter, over 95% of everything that exists is invisible. The stars, the galaxies, the planets, the atoms in your body are a thin residue floating on top of an ocean you cannot detect. If dark energy stays constant, the universe will expand forever. Galaxies will drift so far apart that future civilizations will see nothing but empty sky. Stars will burn out. Space will grow cold. The big freeze. If dark energy strengthens, the outcome is worse. The expansion becomes so violent, it tears apart galaxy clusters. Then galaxies, then stars, then planets, then atoms. Every bond in existence ripped apart from the inside. The big rip. Imagine a force strong enough to overcome the nuclear bonds holding atoms together. Now imagine that force is already active, already accelerating, already winning. We cannot see it. We cannot measure it directly. We do not know what it is, but it makes up more of the universe than everything else combined. And it has already decided how this ends.